Welcome to 222 Lab 1. In this lab, I'm going to describe how you install Codewarrior and how to begin the first lab sequence. First of all, if you have a copy of the PDF for Lab 1, you will notice that you'll have to download Codewarrior from the Freescale website. Now, be warned though that the Codewarrior program is a large program. This latest one that I downloaded is 354 megabytes. So it might take you a while to download that depending upon your speed. You will then go ahead and install the Codewarrior software. It's pretty self-explanatory. In this case, I'm running under Windows 7. This is not my primary laptop. My primary laptop is using Windows XP, so it does run under multiple platforms. And so now that I have already downloaded and installed it, I would like to go ahead and show you how to go ahead and do the example in Lab 1. We have a shortcut here that is created when you do install the program, so we're going to go ahead and double click on that. And the first thing that it's going to ask you is this quick little startup screen, and we want to create a new project, so we will start with that. Now, since I have used this before, it has a drop-down menu box of the different processors that it supports. Now I'm going to collapse those because the first time you will run this, they will not be open. But once you do this and select a certain processor, you will never have to go back and do this again. This is covered in the handout, but I'd like to go ahead and show you anyway. So we are using the HCS12 family of devices, so we will open up that. And then we are subsequently under the HCS12D, that's D as in dog family, so we will then open that. And then specifically, our processor is the 9S12DG128B. So that's this one right here, 9S12DG128B. So we will select that and hit Next. Now once you do that, once again, the next time you run the program, Codewarrior, it will remember that. You would not have to do that again, just the first time. Now, here in this screen, it's going to ask you which type of programming language you're going to use with this instance of Codewarrior. In our case, we are not using C, so we will deselect that, and we will use Absolute Assembly, and that's what we're going to use the entire semester. So remember that and use that subsequently as well. We hit the Next button, and it asks you if you want to add any project files, and we do not need to do that. We'll hit Next again, and there is no need for any application development options, and so we hit Finish. And once that happens, it creates this source tree and some other icons here that we will get into in future labs. But for now, since this lab is strictly about machine language, I would like to have you then go ahead and press the Simulate button or the Debug button. Either way, it's the same idea. It's under Full Chip Simulation here. So we go ahead and press that button, and it's going to open up a second screen here, which is really a separate program, and it is a simulation of the processor. Now notice that we don't have any processor attached to this computer. Everything here is simulated. And that's one of the powerful things about Codewarrior. And since today we are not doing any assembly language, we're doing strictly machine language, I'm going to show you how to enter a simple machine language program, the same one that is outlined on page 3 of the Lab 1 handout. And so to do that, I'm going to drag up this little memory box and then open it up a little bit bigger so we can see what's going on. This represents the internal memory of the processor. Now this is where we are going to enter our machine language program. Now to do it properly, we need to enter this at a certain location. And I'd like you guys to go ahead and use memory location 5000 as the first location for our machine language program. Now you can scroll down to location 5000 if you have a steady hand. I don't, so I'm just going to use the memory button here and go to a certain address, and I can then go ahead and type in 5000 and hit enter. Now this is in hexadecimal, okay, and so notice that we are at location 5000 at this point. Now we want to go ahead and enter the simple machine language program, the example that is on page 3 of the Lab 1 handout, and the first code that goes in is going to be for that first box in the flowchart, which is A equals 30. Now we found that the equivalent machine language for that particular statement is going to be 8630. Now we have to enter that here directly at location 5000. So we can go ahead and double click on that, and we can type in 86. Okay, that represents the first byte. If you hit the tab button, it'll automatically take you to the next location, which is 5001, and we want 30. So that completes the first machine language line of that flowchart. If we hit tab again, now the second line says B equals 40. That equivalent machine language is C640. So we go ahead and hit C6, and then tab 40, tab again. And the final box in our flowchart is simply A equals A plus B, and that equates to 18 tab 06. And that is our complete machine language program. Now if you make a mistake, you can go back and double click on that and then re-enter it without an issue. Now that our machine language program has been entered, we want to go ahead and execute the program. Now before we do so, we have to look over here on the right where it says register. These are the internal registers of our processor. Now notice that the PC register is at 4000. PC stands for program counter. We want that number to point to the beginning of our machine language program. Of course, our machine language program starts at 5000. Therefore, we have to change this value. So we'll go ahead and highlight the value and change that to 5000. And notice the instruction pointer also points to 5000. You must do this because the processor will begin execution at that point, which is where we want our program to begin. Now, let us verify that our program works. To do that, we are going to use this little single step button up here. Okay, and that button, you can use F11 as well. That button actually allows us to then single step one machine language statement at a time. But before we do that, I do not recommend that you blindly start pressing this button. You should really predict what's going to happen first. So if you go back to your flowchart, you notice that the first box says A equals 30. Therefore, I would predict that when I press this button, the value A, which is here in the registers, is going to go from this random value of CB to 40, or 30. So when I press this, let's watch what happens. We single step, and notice that A is equal to 30. Therefore, it executed our first line of code. Notice that the program counter went to 5002, which is the next line in our program, which is C6. So we started at 5000, and now we're at 5002, which should follow our flowchart. The next machine language statement is C640, as you saw in the flowchart, and that's B equals 40. Notice B has a random value of CB. When I single step again, I would expect that B goes to 40. So let's go ahead and press that, and sure enough, B is now equal to 40. And so the final statement in our machine language program is A equals A plus B. So if we add these two together in our heads, we see that A plus B has to be equal to 70, and the result goes to A. So the next time I press the single step, I would expect that A would have the value 70. Notice that our program counter is at 5004, which is the last statement in our program. So let's go ahead and hit the single step, and sure enough, A is equal to 70. And that concludes the simulation of our program. At this point, you can then close the memory box, or you can move it back to where it was. Or if you want to go back and start over again, you can reset the program counter back to 5000. And if you've made a mistake in this program, you can then go ahead and close the simulator altogether, and then redo the flowchart and go back and try it again. Thank you.